with two variables or bivariate data, which just means bivariate. Bi means two, variate means variables, so two variables. Scatter plots help determine if one variable has an effect on the other, or if there's overall trends, patterns, or associations. Associations can be used interchangeably with the word correlation, which was the word that we used yesterday. This set of notes uses association. Yesterday we talked about correlation. They both mean the same thing between the variables. So Susie went to the mall and surveyed shoppers to see how many items they'd purchased in total and the total amount of money they'd spent at the mall. How many shoppers did she survey? How can I tell? Count the number of points. So go ahead and count the number of points. There are 16. Does the number of items purchased have an effect on the amount of money spent?
Yes.
Yes. What is the effect?
The more you purchase, the more you spend.
Right. The more items they bought, the more money they spent. So two variables have a positive association, which we also said was a correlation, when the variables move together. For example, as one variable increases, the other variable also increases. That would be positive. Negative is when two variables have negative association when the variables move in opposite directions. For example, as one variable increases, the other variable decreases. And they show you what this looks like on the side, which we looked at yesterday. Two variables have no association when the change in one variable has no effect on the second variable. So they have nothing to do with each other, and it just looks like a bunch of points everywhere. Describe the type of association you'd expect to see between the following: the hours a person studies and the number of states they've visited. Would that be positive, negative, or no? There would be no association or no correlation there. What about the hours a person studies and their grade on an exam? Positive. As the number of hours you study goes up, so does your grade. So that would be a positive correlation. The hours a person studies, so that goes up. And the hours they spend watching TV. If you study more, you have less time to watch TV, so that would go down. So what kind of association would that be? Negative. If a straight line can be drawn to follow the overall trend of a scatter plot, it is linear. If the points of the data are close together, the association is strong. If the points are widely spread, then we say it is weak. So for each of these, we need to decide if they're positive, negative, or no association, if they're weak or strong, and if it's linear or non-linear. So for this first one, is it which positive, negative, or none?
Positive.
Positive. And is it strong or weak?
Strong.
And is it linear or non-linear? Okay, so we're using a bit of a different definition. It doesn't necessarily mean that it's in a straight line, but just that it has a general straight line pattern. So yes, it does have a straight line pattern, so that would be linear. Number 2, positive, negative, or none? It's still positive. Is it strong or weak? Weak. Those points are getting further apart. And is it linear or non-linear? Linear. All right, number 3. Positive. Positive, strong, and what?
Non-linear.
Non-linear. That does not make a straight line. Number 4.
Negative.
Negative. Yeah, I'd say that's strong. And linear. Number 5. Negative. Weak. And nonlinear. And the last one. No correlation or no association. And if it doesn't have correlation, it's also not going to be weak or strong or linear or not linear. So once you say no correlation, it's just none of the rest of the stuff matters. All right, describe the type of association you'd expect to see between the following variables. A person's height and a person's shoe size. So most of the time, as you grow taller, so as your height goes up, your shoe size also goes up. So that would be positive because both variables increase. The number of letters in your name and your IQ.
No.
Is there any relationship there? No, there is no correlation. The number of absences a student has and the student's GPA.
No. Maybe.
So as the absences increase, what happens to the GPA typically? So that would be negative. More absences causes a lower GPA. All right, in 8 through 10, we need to match the scatter plot with its possible description. So let's start reading the descriptions. The temperature outside and the total gallons of gas sold at the gas station. Would that match 8, 9, or 10? 10. Why 10? Like, it doesn't matter what temperature it is outside, I still have to put gas in my car. The size of a home and the cost of the monthly utilities.
Yes.
So as the size of the home goes up, what happens to the cost of the utilities?
It goes up.
So if they both go up, it's positive. So that would be 9. The altitude of a hiker, so the altitude we're going to say is going up, and the total oxygen level in the air. So as you get higher, there's less oxygen in the air. So that would be 8. All right, we are skipping this page, going on to the next one. Constructing scatter plots. So for this one, Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So first we need to plot this data. For the x-axis, you need to count by 2s. For the y-axis, you can count by 1s. And so do your scale and graph. All right, you should be just about finished graphing. What type of association do you see in the scatter plot? So what if I take this point away down here? We ignore this point and we just look at these points up here. What kind of association would you think that is? That would be a negative. So if we ignore this one point, it really looks like it has a negative association. So it says listening observation. There's one point that's way out to the side. There's one point away from the others. And then there's kind of two groups of points. It says to use the scatter plot to label each statement as true or false. As the distance from the goal increases, the number of baskets made decreases. So as you get further away from the goal, you make less baskets. Is that true or false? True. The further away you get, if you notice, the further away they got, they started making less goals. What about as the distance from the goal decreases, so as you get closer, the number of baskets increases? That's also true. As the distance from the goal decreases, you get closer, the number of baskets made decreases. False. So a point that does not fit the overall pattern of a trend line of a scatter plot is known as an outlier. Who was the outlier in the scatter plot above? Jared. Jared was over here at 14.4. He's way off from everybody else. So Jared was the outlier because his point was far away from the others. Clustering occurs in a scatter plot when there are distinct or separate groups of points. Why do you think the clustering occurred in the scatter plot above?
Because they were all have different skills.
So what were these people doing? How far away from the goal were they?
Not that far.
Were they close to each other?
No.
Yeah, so right here, they're all between 14 and 16 feet away from the goal. So this group stood together. And the same thing with this group. This group stood together as well. So there are two separate groups that stood together. All right, on the next page, it gives you another set of data. This time they've already labeled the graph for you. So we need to plot these points, but notice the population, which is going to be the X, is in thousands. So if like 76,000, you're going to plot at 76. Which, it's not exact, but that's okay. Just get it as close as you can. So go ahead and work on plotting these. Couple more seconds on graphing. Is there any association here? Yeah, what is the association? It's a positive. So what's the relationship?
The higher the population, the more schools they have.
Right, as the population increases, so do the number of elementary schools. Are there any outliers here? What? I heard a yes. Which one? Which one? Glen Falls, yeah. Glen Falls, like, way out here, while the rest of them are kind of all in this line. So the outlier would be Glen Falls. Was much higher than the other data. Are there, is there any clustering? No, there's nothing that's really grouped together. Alright, go ahead and do the bottom box by yourself. The whole thing from start to finish. So the amount of money in the lunch account does not change the amount of homework.
Right.
So are there any outliers? Can there be any outliers if there's no association? No. So there's none because there is no association. Are there any clusters? No. Same reason. All right. So we are skipping the next page. Going to scatter plots and trend lines. When scatter plots demonstrate a linear relationship, a straight line can be used to show the general pattern of the data. A trend line, or line of best fit, is a straight line that should lie as close as possible to the points of data in the scatter plot. So we kind of talked about this yesterday, that you want that line to go through the middle of the points, as close to the middle as you can get it. So for 1 through 4, it wants you to say whether or not it is a good trend line. Is 1 a good trend line? No, most definitely not. It is nowhere near those points. What about number 2? Yeah, that looks to be like it's going straight through the middle. What about number 3? No, it's off to the side of the set of points. What about number 4? No. Alright, so it says to write the equation of the trend line, which is what we did work on yesterday, choose any 2 points on the line. It does not necessarily need to be the dots. It can just be points on the line. And set up the ratio of rise over run to find the slope, or m. Look at the y-axis to find the y-intercept, which is b. And use this to write an equation in slope-intercept form, which you remember is y equals mx plus b. So it's a little different from what we were doing yesterday because we were trying to make it go through 2 points, but they've already drawn the line. So for number 5, I'm going to use this point here and this point here to try to find the slope. So how far down does this go? -1. And then how far over does it go? Over 3. What is the y-intercept of this line? 8. So if I'm going to write that in the slope-intercept form, y equals -1/3 x plus 8. If you still do not know how to find the slope and the y-intercept, you need to get help. You need to watch videos. You need to do something because those 2 things are very important to this whole chapter. You need to be able to find the slope and the y-intercept. Number 6. Pick 2 points. I'm going to go ahead and pick this point and this point. Notice those are not dots. That's just 2 points on this line. So what is the slope? Paying attention to the scale here. Not 1.
Oh, 50? 25?
So this is counting by 25. So that's up 25. And the bottom is counting by 1. So how far over does it go? Over 2. And what is the y-intercept? 100. So y equals 25 over 2 x plus 100. Try the last one by yourself. Pay attention to the scale on the x and y axis. All right, what is the slope here? -10. Don't forget that it's negative because you had to go down and then over. And what is the y-intercept? 45. So y equals what? -10x plus 45. Very good. All right, next page. All right, to find the slope of the trend line below, Riley chose the points 180 and 230. Explain whether those points will help her write the correct equation of the line. What do you think? Why not? Right, those are points from the scatter plot, but they're not on the line. So neither point is on the line. And then it wants us to find the equation of the trend line. So let's go ahead and find the slope. What's the slope for this one? -20. And what is the y-intercept? 90. So y equals what? -20x plus 90. All right, this one they want us to match the scatter plot to this trend line equation, y equals 2x plus 5. So which 2 can I automatically eliminate? A and D. Why can I eliminate A and D? They're negative. What would have to be negative in the equation? The slope. The slope would have to be negative for it to have a negative association like this. So that's not right. So I can just cross out A and D automatically. And then between B and C, which one is it? C. Why is it C?
Because B is over from the y-intercept closer to 5.
Right. The C looks like the y-intercept will be closer to 5, whereas B looks like it's probably like 0 or 1. So the correct answer is C because it has a positive slope and the y-intercept seems to be 5. Alright, go ahead and try this number 10 by yourself. This trend line. 10 over 15, which reduces to 2 over 3. What does the slope mean? So for every how many minutes you study? For every 3 minutes you study, your score goes up how many points? Goes up 2 points. What is the y-intercept of the line? 60. And what does that mean?
You can get a score of 60 without studying.
A student who studied 0 minutes scored 60. And then write an equation for the trend line. Y equals what?
2/3 x plus 6.
Very good. All right, and then we're going to skip another page. Alright, several members of a gym were asked how many minutes they worked out at the gym that day, as well as how many calories they burned. Their answer was used to make the scatter plot on the right. Write an equation for the trend line. So first, what is the slope? So it looks like we go up how much?
300.
And run over.
20.
So 300 over 20 is
150.
15.
15.
And what is the y-intercept? 0. So y equals
15x plus 6.
So I can just write y equals 15x. What does x represent? Time doing what? Doing what? Working out. So it's the minutes spent working out. And what does the y represent? The number of calories burned. How many calories would you expect someone to burn if they spent 120 minutes at the gym? So if we look at this graph, that's going to be off the graph. So I want to use my equation y equals 15x. What do I need to plug in and where? Why do I plug it in for x? X represents the time. So y equals 15 times 120. And you get 1,800. So they would burn 1,800 calories if they spent 2 hours at the gym. What if somebody burnt 1,740 calories? How long were they working out? So where do I need to plug that into my equation? Now let's plug that in for y. So 1,740 equals 15x. What do I need to do to both sides? Divide by 15. So x equals 116, minutes. What is the slope of the line? 15. And what does that represent?
Each minute you burn 15 calories.
For each minute, you burn 15 calories. What is the y-intercept and what does it represent? 0 minutes working out is 0 calories burnt. All right, this next one, pay close attention to. I promise you will see something very similar to this again soon. So, Julie made a scatter plot to show the number of band members at his high school over the years. The trend line has the equation y equals 13x plus 45, so they already gave you the equation. Y represents the total number of band members, and x represents the years since 1990. So this is going to be a little more tricky. So we're using this equation, y equals 13x plus 45. How many students do you predict to be in the band in 1997? What do I plug in and where?
Plus 1397 for X.
So I'm plugging in for x, and what am I plugging in?
1970.
X represents the number of years since 1990. So we're only plugging in 7. So pay attention to that wording here. So we're plugging in 13 times 7 plus 45, which comes out to 136. So in 1997, there should have been 136 members in the band.
Where did I get these equations
From the trend line. All right. How many students would you expect to be members in 2010? So what am I plugging in and where?
from? 20 for X.
We are plugging in 20 for X. 2010 is 20 years after 1990. So Y equals 13 times 20 plus 45. So that comes out to 305. So in 2010, there were probably around 305 members. And what year would you expect the band to have 370 members? What am I plugging in and where? Plug in 370 for Y. So 370 equals 13x plus 45. What do I do first?
Subtract 45 both sides.
So that's 325 equals 13x. Then what do I do?
Divide by both sides.
Divide by 13. So x equals 25. So what year?
2025. Yeah.
Do that math again.
No.
2015. So in 2015, they would have 370 members. In 1960, about 45% of the U.S. population smoked cigarettes. The percentage of the U.S. population that smoked cigarettes over the years since 1960 is shown in the scatter plot. First, we need to write an equation for the trend line. So if I look at the starting point and this point here, what is the rise? Make sure you are paying attention to the scale on this one. Negative what? Negative what? What? I can't hear.
20?
That's negative 25.
Oh, I didn't see.
And then how far over does it run?
40.
40. So negative 25 over 40 reduces to negative 5 over 8. What is the y-intercept? 45. So y equals negative 5/8 x plus 45. What does x represent? Years since the number of years since 1960. What does y represent?
The population of the U.S.
The population that does what?
Population per year?
That smokes cigarettes. So the percent of the U.S. population that smokes cigarettes. What does the slope represent? So negative 5/8 means that for every how many years? For every 8 years. What happens? 5%
Population of people that smoke goes up by 5%.
goes up or down? It goes down. So for every 8 years, 5% less people smoke. What is the y-intercept and what does it represent? So 45% of people smoked in 1960. And what year would you expect 5% to smoke? So where do I need to plug in 5? How do I know it's for y?
Because Y is the percentage of population that smokes.
Right, so we're going to plug it in for y. So y equals negative 5/8 x plus 45. So subtract 45 from both sides. You get negative 40 equals negative 5/8 x. And then what do? So multiply by negative 8/5, the reciprocal, which is 64. So what do I need to do with the 64?
Add it to 1960.
Add it to 1960, and what do you get?
2012.
20 what? 20, not, no.
No. 2014? No.
2024.
2024. That's my third guess, and I got it right.
Shouldn't be guessing. 1960 plus 64 years is 2024. What percentage of the U.S. population would you expect to smoke in 2016? So how many years after 1960 is 2016?
Like 50.
56. Like exactly 56. And where do I plug that into my equation? X. Because X is the number of years. So we get 5/8 times 56 is negative 35 plus 45 is 10. So 10% should smoke in 2016. Go ahead and try that last one by yourself.